Okay, I have a messy radical that I am going to simplify and rationalize the denominator. Simplify is relative here. Okay, this is just a messy radical. So, here goes. I have the radical, the cubed root of 2x to the fourth times y to the fourth all over 9x. Okay, so right away, as I look at the radical, I see that I have variables x to the fourth and y to the fourth. Both of those are larger than 3. So that means I know those will be able to be simplified, even if it's just a matter of factoring out 3x's or 3y's. Then I also know in the denominator I have a 9 and an x. So I'm going to start by changing each of these factors into rewriting them using rational exponents, each individual factor. So that means I have 2 to the 1/3 times x to the 4/3 and times y to the 4/3 all over. Now 9 is 3 squared, right? So I'm going to write this as 3 to the 2/3 times x to the 1/3. Now what this does is allow me to see what I want to multiply the denominator by so that I no longer have rational exponents. So I see 2/3. Well, if I can add 1/3 to that, then I know I have 3/3, which brings me 3 to the first. Likewise, 1/3, if I can add 2/3 to 1/3, then I have x to the 3/3, which simplifies to x to the first. So I would decide to say, well, 3 to the 2/3, if I multiply by 3 to the 1/3, I know I can add those together and get a whole number as an exponent. Likewise, x to the 1/3, I want to multiply by x to the 2/3. Well, let me just erase that there because that's kind of a bad 2/3 there, so I'm going to make it readable. So x to the 2/3, not that that's much better. Ugh. Let me try again. Okay. Now, let's see if I can make this line. Then we have x to the 2/3. Okay. And that's, okay, so I'm going to multiply by 3 to the 1/3, x to the 2/3 in the denominator. But this is when we can only multiply by 1, though. Otherwise, we end up changing the ratio. So this is a special kind of 1, or 1 in disguise. So whatever we do at the bottom, we got to have in the numerator as well. So that's 3 to the 1/3 times x to the 2/3. So I'm really just multiplying by 1. So I'm not changing the value of the ratio. This is a 1 in disguise. So when I do that now, I'm going to put the like factors together. So I'm going to put 2 to the 1/3 times 3 to the 1/3. Okay, and I'll put my x's together. So I have times x to the 4/3 times x to the 2/3 times y to the 4/3 all over. So I have 3 to the 2/3 times 3 to the 1/3. So that gives me 3 to the 3/3, which is cool because that's 3 to the first. And then x to the 1/3 times x to the 2/3. That's x to the 3/3. Okay. So that means now I have 2 to the 1/3 times 3 to the 1/3. Now x to the 4/3 times x to the 2/3. Using our Madspum rules, that means we can add 4/3 and 2/3. So I get x to the 6/3. Okay, and then I have y to the 4/3. Now, in my denominator, 3 to the 3/3 is just 3 to the first, which is 3. And then x to the 3/3 is x to the first, which is x. Okay, so our denominator definitely looks simpler. Okay. Okay, now 2 to the 1/3 times 3 to the 1/3. So that's the same thing as 2 times 3 to the 1/3. Okay, x to the 6/3. Well, 6 divided by 3, right here, 6 divided by 3 is 2. So that means I get x squared. And then y to the 4/3. That's more than 1. So I can break that down as y to the 3/3 times y to the 1/3. And again, this is all over 3x. So now, well, 2 times 3 is 6, so I have 6 to the 1/3. And I'm going to go ahead and put this y to the 1/3 next to it. So we have times y to the 1/3. And then I have x squared times y all over 3x. Ooh, looky, looky. See my x's here? Yeah, I get to cancel one of those bad boys out. So one of those x's are going to go. See, I wouldn't want to be ya. And this x is going to go also. Sorry, I lost. Oh, no, I'm good. So now I have, over here, I have 6 to the 1/3 times y to the 1/3. So that means that's 6. Oh, let me change back to pink here. So that means I have 6 times y, all raised to the 1/3. Okay, and then I have times x times y, all over 3. Well, 6y to the 1/3, that's the same thing as the cubed root of 6y. We have an xy hanging out at front, all over 3. And this is quote unquote the simplified and rationalized version of what we started with.